going to take a look at a Leetcode problem called number of distinct islands. So we're given a m times n binary matrix grid. An island is a group of ones representing land connected directionally, horizontal or vertical. You might assume all four edges of the grid are surrounded by water, and an island is considered to be the same as the other if and only if one island can be translated and not rotated or reflected to equal the other. So for example, like let's say we have a land, right, like this, where one have a block here and then the other block is right here. These are the land, right? And outside of that is the water. And then let's say we have a reflected one, right, which is like this. Like this will not be considered the same. Like they do not equal the same, right? However, though, if they have the exact same shape, like in this case, if this cell right here is right here, right? If there's a land here and there's no land here, right? Then in this case, they are the same, right? They are the same land. So therefore we have one distinct land, right? So in this case, we want to return the number of distinct lands, right? So in this case, we want to return the number of unique islands, right? So you can see here we have an example of this, in this case, this matrix, right? And you can see that 1 represents land and then 0 represents water. So therefore you can see here, this is equal to this, right? So therefore we just have one distinct island. And then if we have something like this, right, where we have one island here, right? This is one distinct island. And then this is one distinct island. And this is one distinct island, right? So total we have 3, right? Because this and this island right here, they are the same, right? They are the same. So therefore we only count as 1, right? So let's take a look at some constraints here. So you can see here that for each and every single cell, we're guaranteed that we can either have 0 or 1, right? An integer value. So in this case, how can we be able to solve this problem? Well, this problem is very similar to the number of islands problem, Leetcode 200. But basically, what we're trying to do is that we're trying to find the number of distinct islands, right? And when we hear the word distinct, we want to use something like a data structure, like a hash set or a table, right? A hash map to be able to store the same islands onto it so that we can be able to keep track of all the distinct islands, right? Or all the unique islands. But in this case, how can we be able to transform, or how can we be able to hash this island into a string or into something that we can be able to identify this is the island and this is the shape of that island, right? So that if we visit another island, we maybe do a DFS or traverse the island, we identify this is the shape of the island, then we can basically just keep track of the unique islands using a set, right? So the bigger question here is how can we be able to hash set, or how can we be able to hash the island, or how can we be able to convert it into a string or something else, right? So just like how we did it in serialized and deserialized binary tree problem, right? What we can do is that we can basically do a DFS or a BFS, right? We can basically traverse the entire land or the entire island, and then we're guaranteed that the order will always be the same, right? The order how we traverse or how we visit the entire island is always going to be the same. So what we can do is that we can basically traverse the island and then convert the shape, right, into a string, and then we can basically save it onto a hash set. So what we can do in this case is that we can do a DFS. I'm going to show you both DFS and BFS way to solve this problem. But basically what we're going to do is that we're going to first go from the top left of the grid to the bottom right. And then once we visit a land, we're going to visit the entire island, right? So in this case, this is our first island, right? So what we're going to do is we're going to do our DFS. The order doesn't matter as long as we keep it consistent, right? So in this case, we can traverse to the top. In this case, the top is basically empty, right? But first we have to go get the current cell, right? In this case, current cell is an island. So what we're going to do is we're going to first define our base coordinate, right? In this case, it's 0, 0, right? So 0 row and 0 column. And then what we're going to do is we're going to get our current cell's distance or current cell's coordinate starting from the base coordinate, right? So in this case, we're going to have a string builder. So in this case, the coordinate for this cell right here is basically 0, right? 0 minus 0, 0. and then the column of this cell is 0, 0 minus the base coordinate is 0. Okay, so what we're going to do then is we're going to search on the top. Top is out of bounds, so we search on the right. In this case, we have a 0, 1, right? That's the coordinate for this cell. And then what we're going to do then is we're basically just going to get the distance starting basically from the actual the base coordinate, right? In this case, the base coordinate is 0, 0, so 0 minus 0 is 0, and 0 minus 1 minus 0 is 1. Okay, and then what we're going to do is we're going to do our DFS. So we're going to visit the top. Top is out of bound. The right is water, and then the bottom in this case is a land. So this right here is basically 1, 1, right? So what we're going to do is we're going to get the current cell, right? In this case, the current cell minus the base coordinate in this case is basically 1, 1, right? And then we visit the top cell. In this case, this is visited. So maybe either we can have like a 2D array to keep track of the visited cell, or we can basically just sink the island and convert this land into a water, right? Can flip the 1 to a 0, basically. Basically, what we're going to do is that this is visited, so we're not gonna add this onto the string. This is out of bound or water. This is water, and there's also this cell right here. So we have 1, 0, right? So this is 1, 0. So we're gonna add it onto here, and basically this coordinate minus the base coordinate in this case is gonna be 1, 0, right? And then once we've done that, we visit the top. In this case, this one is already visited. The right is visited, left is out of bound, and then the right at the bottom is water. So we backtrack to here, and then we already visit the left, and then we backtrack here, we already visit the bottom, and then we backtrack to the root. In this case, we already did it. And then we visit the left, where left is out of bound, the bottom is already visited, the right is already visited. So therefore, this is basically our shape of our island, right? So what we can do is that we can basically just save that string onto a hash set. And then once we visit another hash set, right? Once we visit another land, like for example, this one, what we can do is we can do the same thing, right? We're gonna find our base coordinate. In this case, our base coordinate in this case is this one, right? So in this case, 0, 1, 2, 3, and then 0, 1, 2, right? So 2, 3, that's our base coordinate. And then what we can do is that we can start from here, and then we can basically generate a same string as this one, right? So in this case, this one right here is going to be 2, 3, 2, 3 minus 2, 3. In this case, is going to be 0, 0, right? And then because we're doing a DFS, the order goes this, right? So in this case, we go from the top first, the right, and the bottom, and the left, right? So in this case, we also have this one right here. So in this case, when we traverse or visit the right cell, in this case, it's going to be 3. Actually, no, this is 2, 3. That's 2, 4. So 2, 4. So 2, 4 minus 2, 3 is basically just going to be 0, 1, right? As you can see that this is the same as this one, right? Because we have a base coordinate to be able to convert it into like a common stringify shape, right? So then what we do is that we do our DFS top to the right, basically water and out of bound. And then we do our bottom, right? So in this case, we have 3 and 4, right? So in this case, we just have 1 and 1 in here. And then we do our top. Top is visited, right is out of bound, bottom is out of bound as well. So we go to the left. Left is basically not visited. So we have 3, 3, right? So in this case, we have 1 and 0, right? So you can see here we have 1 and 0, and we append it onto the string, and then we go to the top. Top is visited. This is already visited. This is out of bound. This is water. So then we backtrack to here, and then both 4 directions are visited. So we backtrack to this cell, and then 4 directions already visited. So we backtrack to this cell, and all the directions are visited. So therefore, this is our string. And you can see that if we add this onto the hash set, we only get 1 string. In this case, it's just only this one right here, right? So you can see that we are basically keeping this in a distinct. First, in the DFS way, basically what we can do is that we can first have our constant variables, have our m and n, which is basically the size of our grid, And then we also have a base row and base column. And then we're going to make the grid in a global variable. So first we have our M and N, and we're going to have our hash set to keep track of all the unique shapes. And then we have our grid. And then what we're going to do is we're going to find each and every single island, right? So just like the number of islands, we first find a land. If it's not a land, we just continue, right? So in this case, we're going to have our base row and base column. We have a string file, right? The string builder. And then we basically just go into DFS, right? We're going to pass in the current coordinate because the current coordinate is a land. So we do a DFS here. And then in this case, we pass in a string builder. And then once we come back to string builder, once we done our DFS, we're going to add the current shape onto the hash set. And then at the end, we basically just return a number of unique islands, right? So inside the DFS function, right, you can see here what we did is we check if it's out of bound for sure. If it's out of bound, we just return. And then if it's a water, we just return, of course. And then what we're going to do then is we're going to basically append the current position onto the string builder, right? So you can see here we have the current row minus the base row, and then a column is minus the base column, which gave us kind of like the default, right? The common grid position, right? So you can see here, we're going to use either a comma or another symbol to separate it. This is really optional. You don't really need those commas or symbols. You basically just need those numbers because these numbers will be kind of like universal or just common because we're using the current row minus the base row. And this will basically keep the row number, right, to be basically unique, right? Or not unique, but basically like by default, right? So that is easier to compare. And then what we can do is that we can basically sync the island to mark it as visited, or you can use a 2D Boolean array to mark as visited. And then we search the top all four directions, right? And then at the end, we basically just converting the string builder into a string, and then we just add it onto the hash set, right? So you can see that this is how we're gonna do it in DFS way. And time complexity in this case is basically big O M times N. And then for breadth-first search way, you can do it as well. Basically, right, the logic is the same, but what we did do differently is we're doing the BFS, right? And in this BFS function, we kind of just using a queue, and then we adding the first current position onto it, and then we basically mark the current position as visited, or water converted into water, and we perform our BFS. And inside our BFS, we get the first position, right? So basically BFS, we basically trying to visit the neighbor nodes, right? Or neighbor cells, right? As long as we do it in a constant order, right? So it should be fine. So we add all its neighbors onto the queue, and then we check to see if it's a valid position, right? We check to see if it's not out of bound, if it's not a water, and then we add it onto the queue, and then we just make this current cell as visited, right? So you can see this is basically how we perform this algorithm or solve this problem using BFS, right, and DFS. So the time complexity in this case, you can see is basically going to be big O of M times N, right? Because we're using a set, or in this case, we're using we basically sync the island if it's visited, right? So we're ensuring that we're only visiting each and every single cell once. So there you have it, and thank you for watching.